Right, chapter 8.7 deals with composite functions. And first thing you guys got to know about a composite function is when we place one function inside of another and then we evaluate it. So what I'm going to do is I'm going to give us two functions here. We've got f of x, and that's going to equal x squared minus 4. And then I'm going to give us another function, g of x, and that's going to be 4x minus 1. So first, I want to take this f of x here, and I want to just do a couple of simple plugins that we saw from previous chapters. And the reason why I do this is because you would never think twice about plugging in f of 1. F of 1 is simple. That's just going to be parentheses 1 squared minus 4. And, we don't even have to evaluate this. I just want you to get used to the plugging in aspect of it. F of 2 is going to be 2 squared minus 4. F of negative 4 is going to be negative 4 quantity squared minus 4. And then in chapter 8.1 we got a little more advanced. We did like f of m minus 2, which was parentheses m minus 2 squared minus 4. And then sometimes we even did like an f of x plus h, and that is equal to quantity x plus h squared minus 4. So the bottom line is that anything that goes inside these parentheses is replacing the inside of x. It's replacing the inside of x. So whatever comes up in these parentheses comes up in these parentheses. So let's go ahead and see what this looks like if I compose a function. If I say f of g of x, what this is asking me to do is it's asking me to take g of x and place it inside f of x. Well, what is g of x? Well, from here, if we look back to the left side, g of x is this 4x minus 1. So 4x minus 1 is going to replace the x in f of x. So what I create is parentheses 4x minus 1 quantity squared minus 4. Now this I'm actually going to evaluate. 4x minus 1 quantity squared is 16x squared minus 8x plus 1 minus 4. Now we can further simplify that into 16x squared minus 8x minus 3. And that is what f of g of x equals. All right, again, you're just taking one function and putting it inside of another. If we worked backwards, if we had to say g of f of x, now we're going in the opposite direction. We're going to change to ketchup here. I'm going to take this function and put it inside the x there. So what I get is 4 parentheses x squared minus 4 minus 1. And I can further simplify this by distributing. I get 4x squared minus 16 minus 1. So 4x squared minus 17 is what g of f of x equals. So let's do a few more examples, because I think that with composite functions they can just get a little confusing. The plugging is actually more difficult than the actual chugging. So if I give you two more functions, f of x, and let's say that equals x squared minus 7x plus 4, and I'm sorry, that is supposed to be a squared, and then g of x is going to equal 2x plus 1. If I asked us to find f of g of x, again, the inner function, think about it in terms of inner and outer. The innermost function is g of x, so that means that g of x is going to go inside f of x. Now there are two x's in f of x, so it's going to replace it twice. So that is parentheses 2x plus 1 squared minus 7 times 2x plus 1 plus 4. Let's go ahead and simplify this. This is 4x squared plus, this is 4x plus 1 minus 14x minus 7 plus 4. Let's combine what we can. Those are going to combine to become negative 10x. Those are out. 1 minus 7 is negative 6 plus 4 is negative 2. And I get 4x squared minus 10x minus 2. And that is f of g of x. All right. Let's do the reverse. Let's do g of f of x. G of f of x. Well, that is going to be, again, f of x is on the inside, so we're going to take this whole shebang right here and pump it into this x that lies in front of the 2. So it's 2 parentheses x squared minus 7x plus 4 plus 1. And now I just distribute 3 times. That is 2x squared minus 14x plus 8 plus 1. In other words, 2x squared minus 14x plus 9. And that is g of f of x. Okay? Let's try one more example. If I give you f of x equals x plus 6, and then g of x equals, equals x minus 3. If I asked for f of g of x, that would be easy. We would take g of x and plug it into f of x, so that would be x minus 3 plus 6, which is equal to x plus 3. G of f of x is going to be the opposite. Take this and put it in here. That is x plus 6 minus 3. And what that is that's x plus 3. Wow, same thing. Okay, let's do something a little more complicated looking, but it's actually easier. If I asked you for f of g of 7, what they're asking you to do is they're asking you to just evaluate from the inside out. So take a look at g of 7. Work from the inside out. What is g of 7? Well, g of 7 is really 7 minus 3, which is 4. But remember, we are looking for f of g of 7. So what I have to do is I have to take that 4 and plug it into f of x. So f of g of 7 is really evaluating f of 4. Now f of 4 is 4 plus 6, which is 10. Therefore, I can say that f of g of 7 is equal to 10. Okay, you just take it one step at a time. You handle the innermost function first, and you evaluate for that number, and then you plug it in again. So going based on that, why don't we do f of g of 2? Well, g of 2 is 2 minus 3, which is negative 1. But remember, we're finding f of g of 2, so I got to take this and plug it back into f, so that's f of now negative 1 is equal to negative 1 plus 6, which is 5. We can say, therefore, f of g of 2 is equal to 5. Let's do it backwards. Let's go g of f, g of f of negative 1. Well, f of negative 1, that's what we got to look at first, because f is now the innermost function. That is negative 1 plus 6, which is 5. We take 5, plug it into g. G of 5 is equal to 5 minus 3, which is 2. Therefore, we can say that g of f of negative 1 is 2. Okay, if I asked for f of g of 3, again, take g of 3 first, so g of 3 is equal to 3 plus 1, which is 4. And now I'm looking for f of 4. Well, f of 4 is 4 squared plus 3. 16 plus 3 is 19. So therefore, f of g of 3 equals 19. How about g of f of 2? Well, f of 2 is 2 squared plus 3. 4 plus 3 is 7. So g of 7 is 7 plus 1, which is 8. So we can say, therefore, g of f of 2 is equal to 8. All right. Let's figure out how we do this from a chart. If they were to ask me to find f of g of 3, again, take on the innermost function first, g of 3. Well, g is my row down here. And what happens to g when g equals 3? Well, g is my input, and 3 is the input into g, and when I input 3, I get a 1. So we can say that g of 3 is equal to 1. Now, remember, they're asking you for f of g of 3, so I have to plug this 1 into the f function, which is the top. And so we use the same process. What happens to f when f equals 1? Well, when f equals 1, you end up with negative 7. So therefore, I can say that f of g of 3 is equal to negative 7. In some ways, the chart is actually much, much easier to deal with. Let's take a look at the reverse. Let's take a look at g of f of 3. Let's see what happens now. Well, f of 3 here gives me 0. So f of 3 is 0. And then g of 0, well, g of 0 is 11. So we can say that g of f of 3 is equal to 11. Okay, that's about it. We'll see you next time.